Hello guys, welcome to my YouTube channel. In this part we'll be focusing on differentiation. After we'll be focusing on continuity. There is the relationship between differentiability and continuity. Please note them. The first point is that it is possible for a function to be continuous but not differentiable. Note that, guys. And the second one is that if we have a function f which is differentiable at a point, say a, then f is continuous. On differentiation, guys, note these rules for differentiation. Rule 1, if we have a function f at x which is equal to c, where c is a constant, then differentiation of that function is 0. We denote the differentiation of f at x as f prime x. This is the first derivative. The second point, we have having f at x which is equal to x to the power 1, where n is any real number. Then a differentiation of f at x will be as taking this n, this side to this side, and then subtract the power by 1. And the third one is let's say we have g at x which is equal to constant times f at x. Then the derivative of derivative is the same as differentiation, guys. Don't be confused when sometimes I say derivative. G at x, the derivative of g at x is the same as c times f derivative of f at x. And then the last point is that given r at x, which is the same as f at x plus g at x, this is the same as when you want to find the derivative of r at x, it's the same as this is the same as f at x, derivative of f at x plus g at x. So here we have problems, 4 of them. I'll be using this d over dx of function, and this is the same as f prime. Yes, you can write this or this. Now I'll be using this. I will be using this. Number one, derivative of d over dx of f at x. This is the same as derivative of f at x. This is the same as d over dx of 5. Remember from the rules of differentiation, bullet point 1 says the derivative of a constant number is what? 0. Yes. So number 2, we have that f at x, which is we have that. Okay, let me not waste my ink. Save it. Yeah, d over dx of f at x is the same as d over dx of x to the power 3. Now remember from the bullet point 2, which says bullet point the second bullet point of rules of differentiation says when we have a function x to the power n, it says is that when we differentiate it, it's like we take the power this side and then subtract the power by 1. So let's apply it here. We take 3 to the other side, and then 3 minus 1. This is the same as, let me save space, 3x squared. Yes. And then the third one, These are respective to the bullet points from the rules of differentiation, so that you can understand. D over dx of gx, which is the same as d over dx of 2x to the power 3 plus 2x. So guys, one can ask, since it says the bullet point 3 says gx, which is the same as let me cancel this one, let me write it here. One can ask that since it says g at x, which is the same as c, which one is c here? We can factor out 2, so that we'll be left with the 3 cubed plus x. So c will be our 2, so that when we factor, when we want to find the differentiation of this, we'll get g prime, which is the same as c, meaning 2 will be there, and then left with f prime at x. See, so let's proceed. So there are many ways of doing this, guys. So I'm just doing this thing respective to the rules of differentiation. Maybe I'll show you another way of doing this, which again will be repeating one of the bullet points from the rules for differentiation. Yes, so here you can factor out, like I said, you can factor out 2, you'll be left with this plus x. Well, this is the same as we avoid the constant, take constant to the other side, and then d over dx, and then now we're focusing on this. Yes, and this is the same as 2, and differentiation of this, like differentiating let me do this manually so that you understand what I'm trying to say here. And then this will be the same as d over dx of x cubed plus d over dx of x. Yeah, so 2 has nothing to do with this. And then remember, from the second point in the rules of differentiation, we have that when we have x to the power n, we take that n to that side, and then also subtract 1 from it, and then we have yes, we have the differentiation of x. So this is the same as, remember, x is the same as x to the power 1, right? Yeah, so our power is 1. So I think it makes sense when I even say 1 times x is the same as x. It's the same as x. Yeah, so instead of writing 1, since I take the power to that side, instead of taking it and making it visible, I'll just avoid it because it's the same. So I'll just write x. It's the same as 1 times x, and then 1, then I subtract 1. So what will we get here? Ooh, this page. Okay, let me change. Dang. Oh, sorry. Okay, so let me change this page. Let me take this one. This is the same as 2 3 squared plus x0 Any number to the power to exponent 1 is what? It's any number to the power 0 is the same as 1. So we have 2 3x squared plus 1. So we can factor out, no, not factor out, we can simplify this. 2, so we'll have 6x squared plus 2. Wow, 2 is back now. Okay, so yeah, this is it for my video for now. In the next video we'll be focusing on the differentiating the trig functions, and then also I'll be focusing on the chain rule, the product rule, and the quotient rule. So before I finish up, I want to give you a kind of complex problem so that you solve it, guys. Now just do it for you for just, I'll just take 2 minutes. Okay guys, so this is the challenge for you. Try to solve it. When you're done, pause the video, try to solve it. When you're done, resume the video so that we do it together. Pause the video now. Let me just assume you're pausing it now. You did pause it, you're solving it, you're done. Yeah, you're done. So yes, you're done. So let's you will compare your answer with mine. So the derivative of this f of x, which is the same as d over dx of 1 over 2 x squared plus 4. Yeah, so what do we have to do next, guys? So looking at this thing, we can take we can take 1 over 2 is a constant. We'll be left with this x squared plus 4. Yes, this is the 2 that was in the denominator. Yes, it's in the denominator. So here we take the 2 out. Remember from the blood point, let me check the blood point, the third bullet point from the rules of differentiation. It says this is C, so C, just take it outside, just take it out, and there's nothing to do with all this fight. So we're left with what? We're left with the x 1 over 2 x squared plus 4. So here we have 1 over 2, and again this 2, this 1 over 2 again is C. We can still take it outside, but not outside of this whole thing, outside of when we differentiate this portion. Yes, so here we have d over dx of 1 over 2. This is d over dx. It's kind of scan, and then we have addition d over dx, and we have this. So 1 over 2, this is a constant, you can say 1 over 2, and then d over dx, and then x squared. Yeah, so from the bullet point 1 in the rules of differentiation, says that the differentiation of constant is 0. Remember, yes, we will do it. Gosh, my neighbors too much, always play music. So yeah, 1 over 2, we have from the bullet point, the second bullet point on the rules for differentiation, it says x, differentiation of x to the power n is the same as taking that n and then 2 and then a minus 1. Sorry guys, 1 minus 1, you have to subtract 1 there. So plus, here we have our 0. This is from bullet point 1, and then we have 1 over 2. Then you can simplify this. This is the same as 1 over 2, and we have a 2x to, yeah, 2 minus 1 is 1. It's the same as 1. You can write it. So we have, this is nothing. So we have what? 1 over 2, and then this multiplied by this is x, and then we have what? 1 over 2 times x. This is it. Thank you for being with me through this long journey, guys, up until here. Thank you, guys.